Let ABC denote the outcome of three independent rules of a fair tetrahedral die. Tetrahedral die means you have four faces, and fair tetrahedral die means that chance of getting each face is same, and the different faces are marked with 1, 2, 3, and 4. The question is that if this quadratic equation ax square plus bx plus c equals to 0 has all real roots, the probability of this thing is m by n, where m and n, these two are co-prime numbers. That means there is no common factor between m and n. The greatest common divisor or the HCF of m and n, this is 1. So then we have to find the value of m plus n. So basically the problem is that we have to find the probability that this quadratic equation will have all real roots. If that probability is m by n, then we need to find m plus n. Also, in this quadratic equation, the unknowns a, b, and c, these are obtained by throwing this tetrahedral dice, and on that dice, the different possible outcomes are 1, 2, 3, and 4. So let us say A is the set which contains these four elements 1, 2, 3, 4. So here if I talk about sample space or the number of different quadratic equations that you can create. So for A we have four options, and same thing for B and C, right? In this quadratic equation ax square plus bx plus c equals to 0. For coefficient of x square, that is A, we have four options. Either you can get 1 or 2 or 3 or 4. And same thing for B and C. So using multiplication rule, the number of quadratic equations will be 4 into 4 into 4, which is 4 raised to 3. So these many quadratic equations are possible. Now we have to find the favorable cases. Favorable case means we have to find that how many quadratic equations will be there, which will have all real roots, right? Both the roots must be real. So we know that condition for real root is that discriminant must be non-negative, right? It should be either positive or 0. Then we can get real roots for a quadratic equation. So here the condition will be for favorable cases b square minus 4ac, this must be greater than or equal to 0. And now we have to see that in how many different ways we can select a, b, c, so that this becomes non-negative. Now from here it is difficult to see the different cases, so we can rewrite this equation as we can take AC on other side, and that means we can say that A into C, this must be less than or equal to B square by 4, right? 4AC will be, B square should be greater than 4AC, so that means B square by 4, that should be more than AC or AC less than this number. And now we'll take different values of B and we'll see in how many different ways we can select A and C so that we can satisfy this condition. And remember, ABC can be any number from 1 to 4. So first we'll take different values of B and then we'll see what are the different cases for AC, and from there we can get the number of favorable cases. So on one side we'll write different possibilities for B, and on other side we'll write the ordered pairs AC. So because it is tetrahedral dice and the different faces are marked 1, 2, 3, 4. So for B we have these four options. Either B will be 1 or 2 or 3 or 4. Right? These are the four possible values for B. Now remember, if B is 1, AC should be less than 1 by 4, and A and C also we have to select from here only. So the minimum product that you can create for AC will be 1 when A and C both of them are 1. So in this case we'll not get anything. Right? If B is 1, then you cannot make a quadratic equation with real roots because discriminant will be negative. If I take B as 2, then the condition will be, from here you can see that if B is 2, AC must be less than or equal to 1. So that means there is only one possibility that A is 1 and C is 1. Right? Only when both of these A and C, these two are 1 and 1, then AC will be less than, AC will be equal to 1, and we can satisfy this condition. Similarly, if I take B as 3, then the condition that we need to satisfy is that AC should be less than or equal to 9 by 4. 9 by 4 means 2.25. So A into C, that should be less than or equal to 2 point something. So one possibility is we can take A and C as 1, 1. Another possibility, A is 1 and C is 2. Next possibility, we can have 2, 1. Right, so these are the three possibility. We cannot make 1, 3 because in that case, AC will become more than 2.25. And finally, the last case, if B is 4, AC should be, if B is 4, then if I substitute that value here, so A into C, this should be less than equal to 4. And now we have to see that in how many different ways we can select A and C so that this will be either less than or equal to 4. So if I take A as 1, then you can have starting with 1, 1, we can have 1, 1, 1, 2, 1, 3, and then 1, 4. These four cases you can get if A is 1. Similarly, if I take A as 2, then we have 2, 1, 2, 2. We cannot make 2, 3 because in that case we cannot satisfy this condition. If I take A as 3, then we have 3, 1. We cannot take 3, 2. And finally, we can have 4, 1. So these are the different cases if B is 4. Right? These are the different possibilities for AC. Now, here we are getting one case. Then in this one, we are getting 3. And finally, in this last one, we are getting 4 plus another 4. So that will be 8, right? So that means here total number of cases, I mean, if you count all these different cases, you are getting 12 different cases. So those are the favorable cases, right? Now we have to find the probability that this will have uh, all real roots. So probability is nothing but number of favorable cases by total number of cases. So here we are getting 12 favorable cases. There are 12 quadratic equations for which discriminant will be non-negative and therefore they will have all real roots. And total number of cases, this is 4 raised to 3. You can cancel one 4 from here. So this becomes 3 by 16, right? This will be the probability. This is not the final answer. This will be the probability. Let us say E is the event that we have all real roots. So this is probability of E. And clearly you can see that there is no common factor between these two numbers. So now we can write the answer. The probability is m by n. So that means m must be 3, n must be 16. So m plus n, this will be 3 plus 16, which is 19. So that should be the correct answer for this problem. Right, so this was a problem where we have to, I mean, first use this condition that because it has all real root, discriminant must be non-negative. So it will be either positive or 0. And then write the given condition in this form that A into C, this is less than equal to B square by 4. And from there you can see that for different values of B, what are the different possibilities for AC. So we got 10 favorable cases, sorry, 12 favorable cases, total number of quadratic equation 4 raised to 3. So therefore probability 3 by 16 and hence m plus n, that will be 19, and that is the correct answer for this problem. Out of these 16 squares, 2 squares are selected at random. Find the probability that they have no side in common. Now this is a problem where we have to find that in how many different ways we can select 2 squares so that they have one side in common. And if A is the event, right, A is the event that any two randomly selected square have one side in common. So then we have to find probability of A complement, because when you select any two square, either they will have no side in common or they will have one side in common. For example, if I select a square 1 and 2, then this is the side common between 1 and 2. If I select 1 and 10, there is no side common between those two. So if I say that A is the event that any two randomly selected square will have one side in common, so then we need probability of A complement. And we all know that probability of A complement, this is 1 minus probability of A, right? And now probability of this event A, this will be number of favorable cases by total number of cases. And the total number of cases, it is not difficult to see. Total there are 16 squares and we are selecting any two square. So total number of cases, this will be 16C2. And we have to figure out that how many favorable cases are there. That means in how many different ways we can pick two squares having one side in common. So for a moment, let us focus on this first row. In first row, we have four squares. And if I select a square 1, 2, then we are getting one common side between those two, right? Similarly, if I select a square 2, 3, then also we can get one common side between those two. And if I select square 3, 4, then also we can have one common side between those two squares. So if I talk about row 1 only, right, this is the first row, let us say. So there are three different ways in which you can select a pair of a square having one side in common. 1, 2, or 2, 3, or 3, 4. Now, same thing you can say for the second row also. Let us say this is the second row. So if I have to pick two squares from second row having one side in common, so either you can select 5, 6, or 6, 7, or 7, 8. And now you can see that in this row R3 as well as R4 will have three different ways of selecting a pair of squares having one side in common. Now, same thing you can say column wise also. That means if we talk about this first column now, so if I select a square 1, 5, or 5, 9, or 9, 13, then we can get a side common. So if we talk about this first column, again there are three different ways. Either you can select 1, 5, or you can select 5, 9, or you can select 9, 13. So then you can get one side common, right? So here basically number of ways of selecting a pair of squares having one side in common. This will be 3 into 4 if you select squares row wise. And the same thing you can say for column also. So that means plus another 3 into 4, right? These are the total number of ways of selecting a pair of a square having one side in common. So the total number of cases 16 C2 favorable cases 3 into 4 plus another 3 into 4, right? So that should be the probability of this event A complement, and A is the event that we have one side in common. So A complement means there is no side in common. So now if you calculate this thing, you will get 1 minus 3 into 4, 12, and 12 into 2, that will be 24, and this divided by 16 C2. So that means 16 into 15 into 2. So here I think we can get 1 minus 1 by 5. So that will be 4 by 5. Right, so that should be the correct answer for this problem, second option. So this was a problem where we had to find basically mainly the problem was, I mean, total number of cases will be 16 C2. Mainly the problem was that in how many ways we can select a pair of a square having one side in common. So for that you can think of one row at a time. If you talk about this row, let us say this was row 1. So in row 1 there are three ways of selecting a pair of a square having one side in common. 1, 2, 2, 3, 3, 4. Same thing you can say for second row. Then you can have another 3 square in third row, finally the fourth row. So if you select row wise 3 into 4, 12, and same thing column wise, so another 12, and therefore the required probability will be 4 by 5, and hence the correct answer is second option. Let S be this set. S contains all the natural numbers starting from 1 up to 2022. Then we have to find the probability that a randomly selected number n from this set S will satisfy this condition that HCF of n and 2022, this is 1. Now, problem based on this HCF of a number and another number equals to some fixed number. This is not uncommon in JEE Main. You'll find multiple problems in permutation and combination, as well as few problems in probability based on this concept. So in these type of problem, basically the problem is we have to find how many numbers are there in this set for which HCF of that number and 2022, this will be 1, because obviously total number of cases will be 2022, and we need the number of favorable cases. Then probability will be number of favorable cases by total number of cases. So in such type of problem, the very first step will be that whatever that other number is, write the prime factors of this number. Right, for 2022, the factors will be, you can have 2 and then 1011. So that will be 3 into, and then 337. Right, these are the prime factors of 2022. 2 and then 1011. So that will be 3 into 337. And it is given that HCF of n and this number, this must be 1. Also remember 337 is not when 337 is a prime number, and if I have to check whether 337 is prime number or not, so you can check up to its approximate square root, right? For example, 19 square is 361. So you can check whether this is multiple of 2, 3, 5, 7, 11, 13, 17 up to 19, right? If there are no factors up to 19, then you cannot have both the factors bigger than 19, right? Here, I mean, and the logic is also very simple because 19 is square, this is 361. So for this number, if there are no factors smaller than 19, then there will not be any factor bigger than 19, because if I say that one factor is 23, then other factor has to be less than 19, then only the product will be 337. So whenever you need to check whether a number is prime number or not, you can check up to its approximate square root. And when you check for these numbers, you'll find that this number 337 is not multiple of any one of these numbers. And after this point, you should not check, right? Now here, if HCF of n and this number is 1, so from this line we can conclude that n cannot be multiple of either 2 or 3 or 337, right? This number n, this is not multiple of 2, because if n is multiple of 2, then obviously HCF cannot be 1. Suppose if n was 2, then HCF will be 2. If n is 4, then also HCF will be 2. So n cannot be multiple of 2. Similarly, n cannot be multiple of 3 also, because if n is multiple of 3, then HCF will become 3. And finally, n should not be multiple of 337 also, right? N is neither multiple of 2 nor multiple of 3, and nor it is multiple of 337, right? So now we have to find that how many numbers are there in that set which will satisfy this condition, that it is neither multiple of 2 nor multiple of 3 nor multiple of 337. And for that, here I'll write, first let us see that how many numbers are there which are not multiple of 2, and then we'll consider the other two fact that it should not be multiple of 3 and 337. So if n is not multiple of 2, it has to be an odd number. So the different odd numbers are, you have 1, then you have 3, 5, 7, 9. I'll write just few numbers so that you can see the pattern there, and then the calculation will be much easier. So next you have 13, then you have 15, right? And maybe I can write one more, 17. And in this manner, the last odd number is 2021. And remember, from here we have to remove multiples of 3, and we also need to remove multiples of 337. So if I remove multiples of 3, you cannot take n as 3, because in that case, HCF will not be 1. So it is not 3, it cannot be 9, it cannot be 15, and so on. Now, there is one interesting method of finding how many terms are there which are multiple of 3. Here, if you notice, these are the 3 terms. And out of those 3, one is multiple of 3, other 2 are not multiple of 3. Similarly, if you think of the next triplet, 7, 9, 11, obviously there are multiple ways of solving this one. One, you can use the AP formula. The multiples of 3, 3, 9, 15, and so on, that will form one AP, right? So that also you can do, but this technique will be much easier. So here, out of every 3 number, we are getting one multiple of 3. So here, if we talk about numbers which are uh, satisfying that condition, that means we have odd numbers, total number of odd numbers, this will be 1, 0, 1, 1, right? Total 20, 22, half of them are odd number. So in this series, starting from 1 up to 20, 21, the number of odd numbers are 1, 0, 1, 1. But out of those 1011 numbers, 337 numbers are multiple of 3. How I got this 337? So from these 3 numbers, in every triplet, you have one multiple of 3. Right? In 135, you have one multiple of 3, 7, 9, 11, another multiple of one multiple of 3, and so on. So 1011 divided by 3, that will give us 337 triplets, and every triplet has one multiple of 3. So these are multiples of 3. And remember, we also need to remove multiples of 337, because a number cannot be multiple of 337 also. So now let us count how many multiples of 337 are there. So obviously one number will be 337 into 1, that is present in this series. We are writing only odd numbers, so 337 into 2 is not there. 337 into 3 we have removed with multiples of 3, right? Here when this 337, this these 337 numbers of multiple of 3, they will include 337 into 3, and again 337 into 4 will be even number. So next number 337 into 5. These are and after that 337 into 7 will be bigger than this number. So these are the two multiples of 337 which are present in this series as odd numbers, and we have not removed them as multiple of 3, right? So another two multiples of 337, and this divided by total number of terms 2022. So these are the this should be the probability. Total number of cases 2022, select any one number from there, and number of favorable cases means the number of numbers satisfying this condition that HCF will be 1, that will be 1011 minus 337 minus 2. And after calculation, you will find that this number will become 112 divided by 337. This calculation you can do on your own, and therefore the correct answer will be fourth option. So these HCF type problem, they are not difficult. Just you have to be familiar with the basics that if HCF is 1, the number cannot be multiple of 2 or 3 or 337. Right? First write prime factors of this one, and then total we got these many numbers. After simplification, the correct answer will be option D. An unbiased die means chance of getting each face is same, marked with -2, -1, 0, 1, 2, 3 on different faces, is thrown 5 times. We have to find the probability that product of outcome is positive number. So this is a problem where we have to find that in how many different ways uh, we can make the product of 5 numbers from here positive. Also here if we talk about number of elements in sample space, that total number of possibility. So because we are throwing the dice 5 times, for first throw we have 6 options, any one of these 6 numbers. For second throw again we have 6 options, and so on. So right, for all the 5 throw we have 6 options each, and therefore the number of different possibilities will be 6 raised to 5, right? That will be the number of elements in sample space. Now we have to find that in how many different ways we can make the outcome positive, right? Now as you can see that here we have 3 positive number and then there are 2 negative numbers. If we need positive outcome, then there are different possibility. One possibility is that if I make all the 5 outcomes positive, then their result will be positive, then their product will be positive. So this is one case. If I get positive number in all 5 throws, then the product will be positive. Another possibility will be that if any 2 outcomes are negative, if we have even number of negative outcomes, then also we can make product positive. So any 2 outcome, they are negative, and the remaining 3 outcomes, they are positive. This is another possibility. And finally, the last possibility will be that any one outcome is positive and remaining all 4 outcomes, they are negative. So now we have to see that in how many different ways we can do this one. So, and then obviously let us say E is the event that all outcomes are positive. So probability of A, this will be number of favorable cases divided by total number of cases. As we have discussed earlier, total number of cases, this is 6 raised to 5, right? Because for each of the 5 outcomes, we have 6 possibility. Now let us talk about number of favorable cases. So favorable cases means these 3 cases, right? One case where all 5 outcomes are positive. So if all 5 outcomes are positive, for first outcome we have 3 options. We can take any one of these 3 positive number. For next outcome again we have 3 options. So in this case you'll get 3 raised to 5 number of favorable cases, right? All 5 outcomes are positive. So first one is positive, 3 options, next one is positive, another 3 options, and so on. Second possibility is that any 2 are negative and the remaining 5 are positive. So first select any 2 outcome, right? 5C2, this will represent the different, out of 5 outcomes, you can make any 2 negative. So 5C2 is the number of ways of selecting those 2 outcomes, which will be negative. And the remaining 3 outcomes, they will be positive. Now negative also you can make in 2 different ways, right? For example, let us say first 3 are positive, next 2 are negative. So what is the possible, in how many ways we can make first 3 positive? So first one positive, 3 option, next one positive, another 3 option, next one positive, another 3 option, and two outcomes negative, right? So fourth one negative, two option, and fifth one negative, another two option. So these are the number of cases in this second case, right? 3 cube into 2 square. I mean 3 cube into 2 square, that will represent this particular case, that we have first 3 positive, next 2 negative, and you can arrange this in different ways. So this 5C2 is representing the number of ways to arrange those outcomes, right? I mean, again, I'll repeat this point. 3 cube into 2 square. This is a number of ways of getting first three outcome positive and next two negative. First one negative 3, next one, first one positive 3, next one positive, another 3, and so on. And 5C2 is the different ways to arrange these plus minus sign. Right? If first two were negative, next three positive, still will get the positive outcome. So 5C2 is representing that thing. And similarly, next case, 5C1 or 5C4, maybe 5C4 and 5C1, those two will be same. So select any four outcome, those four will be negative, and the fifth one will be positive. So 5C4 is for selecting any four outcomes, and those four are negative. For negative, we have two options. Let us say, for example, in this case, first one is positive. So for that, we have three options. Next one is first one positive, three options. Next one negative, two options. Right, next four negative, for each one we have two options, so 2 raised to 4. So these are the number of favorable cases, or the number of ways in which you can get a positive product, right? All 5 positive, 3 positive, 2 negative, and then 1 positive, 4 negative. And now you can simplify this one. Once you take 1 3 common, then in denominator you can have 2592. And when you simplify this, you will get 521 in numerator, right? So after calculation, you will get this number, and therefore the correct answer for this problem will be second option. So this was a problem where, I mean, you have to consider these three possibility. If I need positive product, either all 5 positive, 3 positive, any 3 positive, and 2 negative. This one is representing those different cases. And similarly, last one, any 1 positive, remaining 4 negative. And then probability is number of favorable cases by total number of cases. So after simplification, we'll get the second option, and that is the correct answer for this problem. If the numbers appeared on the two throws of a fair six-faced die, fair dice means chance of getting each face is same, and the numbers are alpha and beta. Then we have to find the probability that this quadratic expression x square plus alpha x plus beta, this is greater than 0, right? This one is positive for all real values of x. Now we know that a quadratic expression is always positive if coefficient of x square is positive and the discriminant is negative. That means if I have this quadratic expression ax square plus bx plus c, and if this is greater than 0 for all x, so for that the condition will be that coefficient of x square must be positive and the discriminant must be negative. Coefficient of x square positive means we'll get upward parabola, and d negative means it is not touching or intersecting the x-axis. So in that case, it will be always positive. So here basically when we are throwing two fair dice, so obviously the number of elements in sample space, this will be, for first die we have 6 options, right? And for second die again we have another 6 options. So the number of elements in sample space, this will be 6 square, or the number of different quadratic expressions that you can create here for different values of alpha and beta. For alpha we have 6 value, for beta another 6 value. So number of different quadratic expression, this will be 6 square. Now we have to find that how many quadratic expressions are there which will be always positive, right? This should be greater than 0 for all real values of x. Now here you can see that coefficient of x square is 1. So the first condition is satisfied. Now we need to satisfy the second condition, that discriminant should be negative. Discriminant will be alpha square minus 4 beta. So this should be less than 0, right? Alpha square minus 4 beta, that should be less than 0. So from here you can say that beta must be greater than alpha square by 4, right? This is the condition that we have to satisfy. Beta must be more than alpha square by 4. So now let us take different values of alpha and then see what are the different values of beta that will satisfy that condition. right? So on one side we'll write values of alpha, and on other side we'll write the corresponding values of beta, satisfying the condition that beta is more than alpha square by 4. Also remember that alpha and beta, this will be any one of these first six natural numbers, right? Because when we are throwing a dice, we can get only these numbers. So let us start with alpha equals to 1. On one side we have alpha, another side beta. And for these type of problem, we have to create the table and then see the favorable cases. So if I take alpha as 1, beta should be more than 1 by 4. So you can take any value of beta starting from 1 up to 6. So these are the 6 different cases. Similarly, if I take alpha as 2, and we have to satisfy that beta is more than alpha square by 4. So now if I take alpha as 2, then beta should be greater than 1, right? So the numbers which you can take is, you can take either 2, 3, 4, 5 or 6. We cannot take beta as 1 because beta should be greater than 1, right? Beta should be greater than alpha square by 4. If alpha is 2, alpha square by 4 will be 1. Next possibility is if alpha is 3, right? If I take alpha as 3, then beta should be greater than 9 by 4. 9 by 4 will be 2 point something. We need bigger than 2 point something. So you can take any one of these four values, either 3 or 4 or 5 or 6. If I take alpha as 4, beta should be greater than 4. So either you can take 5 or you can take 6. Finally, if I take 5 or 6, then you can see that if I take alpha as 5, beta should be greater than 6 point something, right? 5 square 25 by 4, so that will be 6 point something. So in this case, you will not get any value of beta. And same thing you can say when you take alpha as 6. Right here, if I take alpha as 6, then also you will not get any value of beta. So you'll get only these cases. Now, how many favorable cases are there? So we have 6 plus 5, that is 11, plus another 6, so that will be 17. Right, that means if E is the event, that quadratic expression is always positive. So total we are getting 17 favorable cases. Also number of quadratic expression that you can create is 36. Number of elements in sample space. So therefore, the probability of this event that this quadratic expression will be positive for all x, this will be 17 by 36. So the correct answer for this problem will be first option. Right, so this was a problem where when first you should know this condition that a quadratic is always positive if A positive and D negative. And then you can see that here uh, A is always positive because A is 1. And for D negative, this is the condition that we are getting, that beta should be greater than alpha square by 4. Now, for different values of alpha, you can take 1, 2, 3 up to 6. But for 5 and 6, we are not getting any value of beta. So only these four cases. And therefore, favorable case is 17, total 36. And the probability will be 17 by 36. Hence, the correct answer for this problem is first option. If the probability that a randomly selected 6-digit number formed using the digits 1 and 8 only is multiple of 21 is P, then we have to find the value of 96P. So basically, we have to find that how many 6-digit number you can create using the digits 1 and 8, and then we have to find that out of those many numbers, how many of them are multiple of 21, right? So here if we talk about number of elements in sample space or number of 6-digit numbers that you can create using the digits 1 and 8. So because we have to create 6-digit numbers, we need to fill 6 places. And for each place, we have two options. Either you can place 1 or you can place 8. So number of 6-digit numbers, this will be 2 raised to 6. For first place, we have two options. For second place, we have two options and so on. So 2 raised to 6, that means 64. Total 64 numbers we can create using the digit 1 and 8. Total 64 6-digit numbers. Now the question is that out of these 64 numbers, how many of them are multiple of 21? Now remember 21 is 3 into 7. So if a number is multiple of 21, then it has to be multiple of 3 as well as multiple of 7. Also, we know that a number is multiple of 3 if sum of digit is multiple of 3, And so that will use as a starting point. First, we'll find that how many numbers are there which are multiple of 3, and then we'll check whether those numbers are multiple of 7 or not. So if I have to create multiple of 3, then we need to make sum of digit multiple of 3. Now, if I have to use only 1 and 8, then there are different possibility. One possibility will be that we can use all the digits as 1, and in this case, the sum of digit will be 6, which is multiple of 3, so number will be multiple of 3. Right now, we are talking about multiple of 3 only. Later, we'll discuss how we can uh, verify whether those numbers are multiple of 7 or not. So this is one possibility. In this case, sum of digit will be multiple of 3, and therefore number will be multiple of 3. Next possibility we can have is we can use 5, 1 and 1, 8. Right? We have to make 6-digit number. So you have started with this case where all the digits are 1. Next possibility is that we have 5, 1 and 1, 8. Now you can very easily see that in this case, sum of digit will be 13, which is not multiple of 3, and therefore any number formed using these digits is not multiple of 3. Next possibility you can consider is 1, 1, 1. We are using 4, 1 and 2, 8. Now in this case, sum of digit will be 16 plus 4, 20. So this will also not work. We have to make sum of digit multiple of 3. Another possibility will be that we can use 3, 1 and 3, 8. Now again, here this number will be multiple of 3. So this is another case where the numbers formed using these digits will be multiple of 3, right? Next possibility will be we can use 2, 1 and 4, 8. 8 into 4, 32 plus 2, 34. Again, sum is not multiple of 3, so number is not multiple of 3. Next possibility will be we can have 1, 1 and 5, 8. Sum of digit will be 40 plus 1, 41. So again, number is not multiple of 3. And finally, the last possibility will be that we can use all 8, right? We can use 6, 8. In this case, sum of digit is multiple of 3, and therefore number will be multiple of 3. Now, in first case, you can make only one number, right? If I use all the digits as 1, and in last case also, you can make only one number. And in this case, you have 6 digits, 3 of them identical, remaining 3 identical. So in this case, you can create uh, 6 factorial by 3 factorial, right? So that, and another 3 factorial. So that will be 6C3, which is 20. So in this case, you can create 20 numbers. And in first and last case, you can create only one number. Remember, we are talking about only those numbers which are multiple of 3. We still have to check whether those numbers are multiple of 7 or not. So these are the 22 numbers, right? Total 22 numbers you can create which are multiple of 3. Now let us write those numbers, at least few numbers, so that we can verify whether they are multiple of 7 or not. So let us say the very first number is we have 1, 1, 1, and then again we have 1, 1, 1. Let us say second number is 8, 8, 8, and then we have another triple 8. And after that, the next 20 numbers are formed using 3, 1 and 3, 8. Right? Using these digits, you can create 20 numbers. Let me write few of them. Maybe one number will be you have triple 8 and then you have triple 1. Fourth number, let us say you have 8, 1, 8, 1, again 8, 1. And in this manner, you can go up to 22. Two number using 6, 1 or 6, 8, and another 20 number using 3, 1 and 3, 8. Let us say this number is maybe 1, 1, 1, and then you have triple 8. And now we have to check that these 22 numbers, are they also multiple of 7? Now see here, we do not have to check for all of these numbers. Here there is one important trick. If you check the first number, you will find that this number is multiple of 7. Right? If you divide this number, triple 1, triple 1 by 7, you will get remainder as 0. So this you can verify. This number is multiple of 7. And once you have established that first number is multiple of 7, all the other subsequent numbers, they are also multiple of 7. I will explain why. See here, this number, clearly you can write this as 8 into, and then you have 1, 1, 1, another triple 1. We have already established that this was multiple of 7. So therefore, this number is also multiple of 7. This next number, this one you can write as, we can have triple 1, another triple 1, plus First three digits were 8, so we can write 777 and then you have triple zeros. Now clearly you can see that this number is multiple of 7 and triple one, this is multiple of 7. This we have checked earlier. So this third number is also multiple of 7. Similarly, any other number you can write as sum of 6 ones plus some multiple of 7. For example, this 8181 you can write in this form. You can separate 1 and then 81 you can write as 7070, another 70. And clearly this is multiple of 7, right? If I want to write the last number, you can write this as triple one, another triple one, and then first three digits will be 0 because we have already separated 1. So this number is 777. Right, we have 61 plus 777. Clearly, this is multiple of 7. This was also multiple of 7. Therefore, this number is multiple of 7. So here, any number that you can create using triple one, triple eight, that will be multiple of 7. And first two numbers, they were also multiple of 7. So we have 22 numbers which are multiple of 7. And total we had 64 numbers. So now we have to find 96p, and p is the probability that a randomly selected number is multiple of 21, right? So we have 22 favorable cases, total number of cases 64. Okay, total 64 numbers are possible, out of which 22 numbers are multiple of 21. So therefore, p will be 22 by 64, and 96p, this will become 3 by 2, 3 into 11, that will be 33. So that should be the correct answer for this problem. Right, so in this problem, the important trick is that you can use, if the number is multiple of 27, it has to be multiple of 3 and 7. The number is multiple of 3, if sum of digit is multiple of 3. So we are getting these three cases. And once you check this number, all the other numbers you can write as triple one plus some multiple of 7. So all of these numbers are multiple of 7 also. And if they are multiple of 3 and 7, they must be multiple of 21. And hence all of these 22 numbers are multiple of 21. And here we had to calculate 96p. So 96, 22 by 64, that will be 33. And that is the correct answer for this problem. Three distinct numbers are randomly selected from this set of first 40 natural numbers, right? The numbers 1, 2, 3 up to 40. If the probability that selected numbers are in an increasing GP, increasing GP means that if first term is positive, the common ratio is greater than 1. So the probability that selected numbers are in increasing GP, this is m by n, where m and n, these two are co-prime numbers, their HCF is 1. Then we have to find the value of m plus n. Now again, this is a problem where we have to consider the different cases, right? Here if we talk about number of elements in sample space, so total 40 elements are there and we are selecting any 3 elements from there. So the total number of ways of selecting 3 elements, this will be 40C3. 40 distinct numbers, we have to select any 3 number. Now next we have to talk about favorable cases. Favorable cases are those cases where those selected numbers are in a GP with common ratio greater than 1, right? Increasing GP, because all the numbers are positive numbers, so we'll get an increasing GP when the common ratio is more than 1. So here we have to count, basically the problem is we have to count that in how many different ways we can select 3 numbers so that they will form an increasing GP, right? And then our probability will be number of favorable cases by total number of cases. Total number of cases is 40C3. Now see, for finding number of favorable cases, we have to consider the different possibilities. So basically we have to think about the common ratio R, and then we have to see that how many different GP we can create. Also, because it is an increasing GP, common ratio must be greater than 1, right? So on one side we'll write R, and on another side we'll see how many different GPs are possible. Increasing GP, common ratio more than 1, and because all integers are there in this set, so common ratio must be integer, right? It cannot be fraction because then you will not get terms from this set. So if the common ratio is greater than 1 and it is an integer, so it has to be either 2 or 3 or 4 and so on. Now, suppose if I take common ratio as 2, so let us see how many GP we can create with common ratio 2. One possibility is that first term we can take 1. If common ratio is 2, next term will be 2, and then next one will be 4. So this is 1 GP with common ratio 2. Similarly, if I take first term as 2, the next term will be 2R, and the next one will be 2R square. So this is the next GP, 2, 4, and then 8. You can see that if first term is 3, then next one will be 3 into 2, 6, and then 6 into 2, 12. So in this manner, we can create number of GPs. And the last one is, if I take 40 as the last term, then the second last term will be half of that. So that means 20. And the third last term, I mean the first term of that GP will be 20 by 2, that is 10. So in this, if the common ratio is 2, then these are the 10 GP that we can create. Right? If we see the first term only, I mean how many GP are here? So just notice the first term, 1, 2, 3 up to 10. So 10 GP we can create if the common ratio is 2. Now think of the next possibility. If the common ratio is 3, then first term 1, next one will be 1 into 3, and next one will be 1 into 3 square. So 139. This is a GP with first term 1, common ratio 3. Another possibility is that we can have 2, 2 into 3, 6, 6 into 3, 18. And you can see that we'll get only a few GP because I mean here every number we are multiplying with 3, and once you cross this last number 40, then you cannot have terms from here, right? So that means next possibility will be if I take first term as 3, 3 into 3, 9, and then 9 into 3, 27. If I take first term as 4, 4 into 3, 12, 12 into 3, 36. And if I take first term as 5, then next term will be 15, and then 15 into 3, 45. 45 is not there in this set, right? The moment you cross 40, I mean, we have to stop counting. So these are the 4 ZP, common ratio 3. Similarly, if I take common ratio 4, then we'll get 1, 4, 16. This is one possibility. If the first term is 2, then we can have 2, 4 into 2, 8, 8 into 4, 32. And if I take 3, then we'll get 3, 24, sorry, 3 and then 12 and then 48. So again, bigger than this number. So there are only 2 GP with common ratio 4. These are the 2 GP. First term 1, 4, 16, first term 1 and then 4 and 16, or 2, 8, 32. Similarly, if I take first term as common ratio as 5, then first term we can have 1, 5 and then 25, and the next one will be 2, 10 and 50. Now again 50 is not there in that set, so there is only one GP with common ratio 5. If I take common ratio 6, then we can have 1, 6, 36. Again there is only one GP with common ratio 6, and with 7 you can easily see that the even if I take the first term as 1, the GP will be 1, 7 and then 49. Again 49 is bigger than this number. So these are all the different increasing GP. Right, first we have to take the common ratio, and then we have to count how many GP we can create, considering the fact that we have to take numbers, we have to select the numbers from this set, from the first 40 natural numbers. So now these are all the favorable cases, right? We got 10 GP here, 10 plus 4, 14, plus 2, 16, plus another 2, 18. So if uh, and it is given that probability that will get increasing GP, this is m by n. So that means m by n, this must be number of favorable cases by total number of cases. Number of favorable cases 18, and then total number of cases, this we are getting 40C3. Total 40 numbers are there. Select any 3 number, and that will give us one case. So number of elements in sample space 40C3, favorable cases 18, and after simplification, you can do the calculation on your own. You will get 9 divided by 4940. So these are the, this will be the value of m by n. And there is no common factor between these two, right? 4940 is not multiple of 3. So these two numbers are co-prime numbers, or their GCD or greatest common divisor is 1. So now we need to find m plus n. So clearly you can see that if I add these two numbers, we'll get 4940 plus another 9. So that is 4949. So this should be the correct answer for this problem, right? So this was not a difficult problem. Just count the different cases. Total number of cases 40C3. And for favorable cases, we have to consider the different common ratios. And because we have increasing GP, so common ratio should be greater than 1. And only integers are involved here, so common ratio cannot be fraction. So we have to start with common ratio 2, 3, 4 up to 6. And then we got 18 favorable cases, total 40 C3. After simplification, the answer will be 4949. Let the sum of two positive numbers be 24. If the probability that the product is not less than 3/4 of their greatest possible product is m by n, where again m and n, these two are co-prime numbers. So we have to find the value of n minus m. Now, first here we'll count that how many elements are there in sample space, and then we'll try to calculate the favorable cases. It is given that sum of two positive numbers is 24. So let us say those two numbers are x and y. So x plus y, this must be 24, and it is given that x and y, these two are positive integers. So the different cases will be, when if I have to find two positive integer and we need to make their sum 24. So one possibility is that first number is 1, second number is 23. Another possibility is first number is 2, second number is 22. And in this manner, the last possibility will be that first number is 23 and the second one is 1. So clearly you can see that number of elements in sample space or number of ways of finding two positive integers whose sum is 24, this will be 23, right? Now we have to count number of favorable cases, and this one is the interesting part of this problem. We have to find number of favorable cases, and favorable case means that product of those two numbers is not less than 3/4 of, not less than means either greater than or equal to 3/4 of their greatest possible product, right? Now we know that if we have two positive numbers and their sum is constant, then their product is maximum when the two numbers are equal. For example, there are different ways in which you can create 24 here. So one possibility 1 into 3, right? 1 and 23. If you multiply these two numbers, you'll get 23. When you multiply these two numbers, you'll get 22 into 2, 44. So in this manner, the product will be maximum if you make the two numbers equal. That means maximum value of x into y, right? Total 23 cases we are getting, and out of these 24 cases you will get maximum x into y when x is 12 and y is 12, right? Clearly you can see that if I take x 12, y 12, then the product will be 144. If you take x13, y11, the product will be 143. If you take x14 and y10, the product will be 140 and so on. So the product is maximum when you make the two numbers equal, right? Now here it is given that the favorable cases are those cases where the product of these two numbers, that means x into y, this is not less than, that means greater than or equal to 3/4 of their greatest possible product. Greatest possible product is 144. So that means x into y, this must be greater than equal to 36 into 3. So that will be 108. So now we have to count that out of these 23 cases, total we are getting 23 different cases. So out of these 23 cases, how many cases are there where x into y, this is either 108 or greater than 108. Those are the favorable cases, right? So here, if we count the different possibility, we can start with x12, y12, because here you will get the maximum product, and then we'll keep on increasing one number by one and we'll decrease the second number by one so that we can maintain the sum of 24. So next we can take 11 and 13. Product of these two numbers 143, and clearly it is more than 108. And remember, from here you will get two different cases, 11 13, 13 11. Next possibility will be 10 14. 10 into 14, 140, that is certainly greater than 108. Next again you will get two cases from here, 10 14, and by interchanging those two, 14 and 10. Similarly, next one will be 9 and 15. 9 into 15 is 135, which is more than 108. Next one will be 8 into 16. Next possibility will be 7 into 17, right? 7 into 17 will be 119, which is greater than 108. Just decrease one number by one and increase the second number by one and see how many cases we are getting. Next possibility will be 6 and 18. 6 into 18, 108. Here it should be either greater than or equal to. Not less than means uh, either more than or equal to that number. So 6 and then 18, this will be 108. If you take 5 and 19, then 19 into 5 will be 95 and then the product will become smaller than this number. So these are all the favorable cases. Right now, first case 12, 12, that will give you only one case. But in remaining all cases, you are going to get two different cases. So here you can see that 3 plus another 3, 6 into 2 because we can interchange those two. So 12 and plus 1 this case 12 and 12. So these are the 13 favorable cases, right? These are the 13 cases where some of the two numbers will be 24 and their product will be either greater than or equal to 108, right? So here this probability m by n, this will be number of favorable cases, which is 13 divided by total number of cases 23. We have to find n minus m, and remember this should be in lowest form. So clearly there is no common factor between 13 and 23. In fact, both of them are prime numbers. So here if you calculate the difference of those two, n minus m, 23 minus 13, that will be 10. And therefore the correct answer for this problem will be first option. Right, so this was again a problem on basic concept that you have to be aware of this fact that product of two number is maximum. Two positive number, if their sum is constant, the product is maximum when the numbers are equal. And from there we got this favorable case that x into y should be greater than greater than equal to 108. 13 favorable cases and total 23 cases. So therefore probability will be 13 by 23. And finally the correct answer for this problem is first option. Let S equals to omega 1, omega 2 up to infinity. This be a sample space associated with a random experiment. Probability of omega n, this is half of probability of omega n minus 1, where n is greater than equal to 2. A is the set containing these elements. A is containing all the elements of this form 2k plus 3l, where k and l, these two are natural numbers. B is the set containing omega n, where n is taken from set A, n belongs to A. Then we have to find the probability of this event B. Now, in this problem, there are a number of relations that we have to decode. The very first one is that probability of omega n. This is half of probability of omega n minus 1, where n is more than equal to 2. So let us say probability of omega 1, this is some constant k. So that means probability of next event omega 2, this will be half of probability of omega 1. So this will be half of k. Similarly, the probability of this event omega 3, this will be half of probability of omega 2. So that means you'll get 1 by 2 square and this multiplied by k. And in this manner, it will continue up to infinity. Now, omega 1, omega 2, these are events of a sample space, right? So therefore, sum of the probability of all of these events must be 1, right? Probability of omega 1 plus probability of omega 2 to infinity, that must be 1. So if I add all of these probability and if I take k common, then you will get 1 plus 1 by 2. Next term will be 1 by 2 square. Probability of omega 4 will be 1 by 2 cube into k. So 1 by 2 cube up to infinity. This sum must be 1. And now we have infinite GP, for which we have standard formula A by 1 minus R. A is 1, common ratio is 1 by 2. So this sum will become 2, right? 1 by 1 minus 2, that will be 2. So from here we are getting 2k as 1. And that means the value of k, this will be 1 by 2. So probability of omega 1, this will be 1 by 2. Probability of omega 2, this will be 1 by 2 square. Probability of omega 3, this will be 1 by 2 cube and so on. And in fact, if you want, you can write the general formula that probability of omega n, this will be 1 by 2 raised to n. So this is the first information that we got from here. Now the second relation that we need to decode is that set A contains all the elements of this form 2k plus 3l, where k and l, these two are natural numbers. So let us say what are the different elements present in this set A. Right, in set A, the different elements will be. If I talk about the smallest element present in set A, we can take k and l as 1 and 1. They are natural numbers, so the least value of k will be 1 and least value of l is also 1. So that will give us 3 plus 2, that is 5. Now the next element that we can create is 6. You cannot create because if I take l as 2, k will have to take 0, but we cannot take 0. Least value we need to take 1. So the next smallest value will be, if I take k as 2 and l as 1, then 2 into 2 plus 3, that will be 4 plus 3, 7. So this is the next element of set A. After this, if I have to create 8, you can take L as 2 and K as 1. So 3 into 2, 6 plus 2, that will be 8. And after this, all the elements you can create. For example, if I need 9, you can take K as 3 and L as 1. So 2 into 3 plus 3, that will be 9. If I need 10, you can take K as 2 and L as 2. So 2 into 2 plus 3 into 2, that will give us 10. So in set A, we have all of these elements starting from 5 up to infinity except 6, right? Now, B is the set containing all these events omega n, where n is taken from set A. So that means B is omega 5, then you have omega 7, omega 8, and in this manner it will continue up to infinity. And now the question is, what is the probability of this event B? So sum of all the probability starting from 1 up to infinity, this will be 1. So if I need probability of event B, this we can say is this will be 1 minus probability of, and all those events which are missing in this set. So 1 minus probability of omega 1, I mean 1, 2, 3, 4, those 4 terms are missing, and then 6 is missing. So probability of event B, this will be 1 minus probability of omega 1 plus probability of omega 2, probability of omega 3 plus probability of omega 4. 5 is there, and starting from 7 up to infinity we have all the terms, but the term 6 is missing, so probability of omega 6. So this should be probability of event B. Now this will become, for omega n, we have this formula that probability of omega n, this is 1 by 2 raised to n, right? This we have established earlier, that probability of omega n is 1 by 2 raised to n. So now for omega 1, the probability will be 1 by 2. For omega 2, it will be 1 by 4. For omega 3, it is 1 by 8. Omega 4, 1 by 16. And omega 6, that will be 1 by 64. So this will be the required probability. Now you can do the calculation. After calculation, you will find that this number will be 3 by 64. And therefore, that should be the correct answer. Right, so in this problem, the important concept was that probability of sample space, that will be 1. So if I add all these probability, that sum should be 1. From there, we got the value of k as 1 by 2. And then we established that probability of omega n 1 by 2 raised to n. And then in set A, we have all the natural numbers except the numbers from 1 to 4, and then this number 6. So in set A, we had these elements starting from 5 up to infinity except 6, and B was this set. And finally, after calculation, probability of event B, this was 3 by 64, and therefore correct answer will be option D. Let n be a number that turns up when a fair die is rolled. If the probability that this system of linear equation has unique solution, this is k by 6, then we have to find sum of all possible values of k and all possible values of n. Now, as you can see that in this system of linear equation, we have a system of linear equation, 3 equations, 3 unknowns, and equation 2 and 3 has this unknown n, right? In equation 3, the coefficient of z is n. Similarly, in equation 2, the coefficient of y is n. And n is a number that we are getting when we are throwing a fair dice, right? So n will be any one of the first 6 natural numbers. N will be either 1 or 2 or 3 up to 6. So if we select any one number from here, then we have to find the probability that this system of linear equation will have unique solution. Now remember, the condition for unique solution is that determinant of coefficient matrix must be non-zero, right? That is the condition for unique solution, that if determinant of coefficient matrix, that is delta, is non-zero, then the system of linear equation will have unique solution. So, first we'll calculate the determinant of coefficient matrix by equating that to non-zero. We'll see what are the possible values of n, right? What are the favorable cases? Total number of cases will be 6. There are 6 possible values of n. Now let us find out that how many values of n are there, which will give us unique solution. So then the probability will be favorable cases by total number of cases. So here for unique solution, the determinant of coefficient matrix that should be non-zero. Now, as you can see that in coefficient matrix, the first row will be 1, 1, 1, coefficients of x, y, and z in first equation. Similarly, the second row will be 2, n, and 2, again coefficient of x, y, and z in second equation. And the third row will be 3, 3, n. So this is the determinant of coefficient matrix. And if the system of linear equation has unique solution, then this determinant must be non-zero, right? Now, if you want to solve this one, if you want, you can create two zeros and then you can expand, because first row has 3, 1, or directly also you can expand. It will not take much time. If I expand along first row, then we are going to get 1 into n square minus 6 minus 1 into, and then we have 2n minus 6 plus 1 into, and then we have 6 minus 3n. So this is the determinant of coefficient matrix, and this should be non-zero. Now from here you can see that this minus 6 plus 6 will cancel. So we are getting n square minus 2n minus 3n. So that will be minus 5n plus 6. This is non-zero, right? And now by splitting the middle terms, we can create the factors. So we are going to get n minus 2 into n minus 3, and this is non-zero. Now here there is one important concept. The product of two number is 0. Let us say if x into y is 0, then we say that either x is 0 or y is 0. But if product of two numbers is non-zero, then it means both the factors will be non-zero. That means n minus 2 is non-zero, which means n is not equal to 2. And n minus 3 is non-zero, that means n is not equal to 3. This is one important point, because if product is 0, then if any one factor is 0, it will make the product 0. But if the product is non-zero, then both the factors must be non-zero. That means here n minus 2 is non-zero, which means n is not equal to 2, and n minus 3 is non-zero, that means n is not equal to 3. So we'll get unique solution for this system of linear equation if n is neither 2 nor 3. So the favorable cases will be the value of n should be either 1 or 4, 5, 6. These are the four favorable cases. If n is either 2 or 3, then the system of linear equation will not have unique solution, right? So clearly we have four favorable cases. The favorable cases will be n is 1 or 4 or 5 or 6. So there are four favorable cases and total number of cases are 6. So this is the probability that the system of linear equation will have unique solution, and this probability must be k by 6, which is given. So from here clearly you can see that the value of k will be 4. Now the question was that what is sum of all possible values of n and all possible values of k. There is only one value of k, which is 4, and there are four possible values of n. N can be any number other than 2 and 3. So the possible values of n are 1, 4, 5, and 6. So this will be sum of all possible values of k and all possible values of n. After adding this, 10 plus another 10, that will be 20. And therefore, correct answer for this problem is option C. Right, so this was not a difficult problem. From consistency of system of linear equation, you have to know this condition that for unique solution, determinant of coefficient matrix is non-zero. And if determinant of coefficient matrix is non-zero, we are getting this condition that n is not equal to 2 and n is not equal to 3. So four favorable cases, right? All of these except 2 and 3, these are favorable cases. And total 6 cases, probability 4 by 6. From there we got k as 4. Sum of all values of k and n, that will be 20. And hence correct answer is option C. Find the probability that a randomly selected 2 cross 2 matrix with all its entries from the set of first 10 prime numbers is singular matrix, right? Singular matrix means determinant of that matrix is 0. So let us say that these are the different prime numbers. First 10 prime numbers will be starting from 2, 3, 5. Then you have 7, 11, 13, right? Then next will be 17, 19. Then you have 23 and 29. So these are the first 10 prime numbers. Now the question is that using these 10 prime numbers, of 2 cross 2 matrix is created, and we have to find the probability that that matrix will be a singular matrix, right? Now let us say this is our 2 cross 2 matrix A, and there are 4 unknowns in that. Let us say those unknowns are A, B, C, D. So here we have this matrix. In first row, let us say we have A and B, and in second row, we have C and D. So first of all, let us find the number of elements in sample space, or the number of matrices that you can create. A, B, C, D, we have to select from this set, right? A, B, C, D are selected from first 10 prime numbers. So for A, we have 10 options. We can select any one of these 10 numbers. Similarly, for B, we have another 10 options and so on. So total number of matrices that you can create, this will be 10 raised to 4, right? For A, 10 option, for B, another 10 option and so on. So these are the total number of matrices, or the number of elements in sample space. Now let us count the favorable cases. Favorable case means out of these 10 raised to 4 matrices, we have to find that how many matrices are singular matrix. How many matrices are there whose determinant is 0. Now, see, singular matrix you can create in different ways. One possibility is that you will pick any one number from here, and you will use the same number in all entries. Right? For example, let us say if I create a matrix like this, where we have selected any one number from there. Let us say we have selected 2 or 3, any number, and then all the entries are same number. Now, what is the determinant of this matrix? Obviously, the answer is 0, right? So, this is one singular matrix. Now, how many such singular matrices are possible? So, let us say n1 is the number of such singular matrices where all entries are same. So, this will be nothing but 10C1, right? Out of these 10 elements, select any one element and will use the same element 4 times. So all of these 4 variables A, B, C, D will be that same element. So there will be 10 such singular matrices. Another possibility is, second possibility will be that out of these 10 prime numbers, select any 2 prime number and will keep those prime numbers either in, let us say we have selected these 2 prime numbers, maybe 5 and then 7. You can select any 2 from there. So you can keep 5 in first row and 7 in second row. Now again, the determinant of this matrix will be 0, right? If I want, I can keep 5 in first column and 7 in second column, still the determinant will be 0. So let us say N2 is these type of matrices where we are using any 2 of these 10 elements. Now, how many such matrices are there? So, step 1, from those 10 matrices, select from those 10 elements, those 10 prime numbers, select any 2 prime number. Let us say we have selected 5 and 7. Now, in how many ways we can do that selection? 10C2. And once you select 5 and 7, there are 4 matrices that you can create. What are those matrices? First matrix where 5 is in first row, 7 in second row. Another matrix where 5 is in second row and 7 in first row. Just interchange these 2 rows. And same thing you can do column wise, right? Or another way of saying the same thing will be that you need to keep uh, the elements of any one row or any one column same. So one matrix where 5 is in first row, another matrix where 5 is in second row, another matrix where 5 is in first column, and finally the last matrix where 5 is in second column, right? So by selecting these 2 elements for corresponding to each selection, we can create 4 such matrices, right? 5 in row 1, 5 in row 2, and that means 7 in row 1, 5 in first column and 5 in second column. In all those cases, determinant will be 0. So the number of such matrices will be 10C2 is 45, 10 into 9 by 2, and that multiplied by 4. So 45 into 4, that means 90 into 2, so that will be 180. So these are the number of matrices where we are using exactly 2 of these 10 elements. Now, using 3 or 4 elements, you cannot create a singular matrix for the simple reason that all of these numbers are prime numbers. Right? For example, if I select 5, 7, and 11, so now you cannot make AD minus BC 0. Right? For example, I mean, because all of them are prime numbers, so singular matrix means determinant should be 0. Now, if you select any 3 prime numbers from here, you cannot get 0. AD minus BC, that cannot become 0. And similarly, if you select any 4 prime numbers, then also you cannot make AD minus BC 0. Right? AD minus BC 0 means AD is same as BC. Now, product of any two prime number, this will not be same as product of any two other prime numbers. Right? If I have selected these 4 prime numbers, so A into D is not same as B into C if they are different numbers. So therefore, these are the only two matrices, right? These are the only two possibilities that we have. Either all 4 elements are same or any two are same, remaining two are same, and the same elements are in any one row or any one column. So now the question is we have to find the probability that the matrix will be singular matrix. So total number of singular matrix, this we are getting 190, right? 180 in second case, 10 in first case, and this divided by 10 raised to 4. So after simplification, this will be 19 by 10 raised to 3, and therefore the correct answer for this problem will be option C. This was an interesting problem, and because all the prime numbers are involved, so we are getting only these two cases, because product of any two prime number is not same as product of any two other prime numbers. So 190 favorable cases, total 10 raised to 4, probability will be 19 by 10 raised to 3, and hence the correct answer is option C. Let A be a square matrix of order 2 with entries either 0 or 1. So we have a 2 cross 2 matrix and each entry is either 0 or 1. Let E be the event that matrix A is invertible matrix. Invertible matrix means determinant of that matrix is non-zero. So then we have to find probability of this event E. So first let us find the sample space here. We have a 2 cross 2 matrix and the entries are either 0 or 1. So let us say we have a general 2 cross 2 matrix with entries A, B, C, D. First row is A and B, and the second row is C, D. Now each entry is either 1 or 0. So that means for each one of these 4 elements of this matrix, we have 2 options, right? So therefore, number of elements in sample space or number of matrices, this will be 2 raised to 4 or 16. For A, we have 2 options. Either we can take A as 0 or 1. For B, we have another 2 options and so on. So using multiplication rule, the number of matrices that you can create, this will be 16. Now let us talk about favorable cases. Favorable cases are those cases where determinant of matrix is non-zero. So total we have 16 matrices. First we'll find those matrices whose determinant is 0. Right, first we'll count the number of matrices whose determinant is 0. Determinant 0 means AD minus BC, that thing is 0. Right, and total we have 16. So the remaining matrices will have determinant non-zero. Now, if I want to make determinant 0, then there are number of different possibilities. The very first possibility will be, I mean, we have to use only 0 and 1. So we'll consider different cases. One case we'll consider where we are using all zeros. Next case we'll consider where we are using 3 0 and 1 1. And then we have 2 0, 2 1, right? And in that manner, we'll see what are the different cases that we can create. So the very first case we are creating is where I'm using only zeros, right? We are using all the 4 0 and we are not using any 1. So in this case, clearly you can see that you'll get one matrix whose determinant will be 0. First we'll count number of matrices having determinant 0, and then total minus those matrices, that will give us number of invertible matrix, right? So one possibility we are using all 4 elements as 0. Next possibly, in this case, you'll get only one matrix, right? There will be only one matrix with all entries 0 and determinant is also 0. Next possibility is that we can use 3 0 and 1 1, right? We are using 3 zeros and then we have 1 1. Now, in this case, how many matrices are possible? So clearly you can see that in this case, you can create four such matrices. In first case, you'll get only one matrix, but in this case, you will get four matrices by changing the position of this element 1. Right? This one will be either in first row, first column, first row, second column, and so on. So in this case, we are going to get four matrices. Next possibility is that we can use two zeros and two one. Remember, in first case, we were getting only one matrix, right? In this case, we got 1. In second case, we got 4. Now, next possibility is that we are going to use 2, 0 and 2, 1, and then again count how many matrices we can create. So, again, if I have to use 2, 0 and 2, 1, we need to keep those two zeros in same row or same column, right? So, for example, this is one matrix whose determinant will be 0. Now, in this particular matrix, we are taking two zeros in first row, but we can take two zeros in second row also, or first column or second column. So here again, you can create four matrices using two zeros and two one whose determinant will be 0. Remember, if I have 0 on diagonal and off diagonal elements are 1, then determinant is non-zero, right? So these are the four matrices will be first row 0, second row 0, first column 0, and second column 0. So these are the four matrices that you will get when you are using two zeros and two one. Next possibility is if I use only one zero, if I use only 1 0 and 3 1, then you cannot make determinant 0, right? In the same example, you can see that if I use only 1 0 and 3 1, then determinant will be non-zero. So in that case, we'll not get any matrix. And so the last case will be that if we are using all 1 and none of the elements are 0, then also you can get a matrix with determinant 0, right? If all the four entries are 1, then also determinant will be 0. So here we are getting one matrix, right? So if we talk about total number of matrices with determinant 0, clearly you can see that 4 plus 4 plus another 2. So there are 10 matrices whose determinant is 0. So that means for remaining 6 matrices, the determinant will be non-zero. And therefore, probability of this event E, that a randomly selected matrix will be invertible matrix, this will be 6 by 16. Right? There are 6 matrices with determinant non-zero, total 16. So this will become 6 by 16 or 3 by 8. And hence the correct answer will be option E. So this was a very simple problem and you have to just count the different cases. So always start with the extreme case and then see what are the different possibilities, right? For favorable cases, first we are counting those matrices whose determinant is 0. Now you can use 4 0 or 3 0 1 1 or 2 0 2 1 or 1 0 3 1, but in that case you will not get determinant 0, and finally all 4 1, right? So we have considered all the 5 possibility and these are the number of matrices whose determinant is 0. So remaining 6 matrices will have determinant non-zero and hence probability will be 6 by 16 or 3 by 8, and the correct answer for this problem will be first option. Let S be this set containing first 6 natural numbers. Then find the probability that a randomly selected onto function means codomain is same as range. So find the probability that a randomly selected onto function g from S to S satisfies this equation, that g of 3, this is twice of g of 1. Now in this problem we have to first find the total number of onto function from S to S, that will give us number of elements in sample space, and then we have to find that how many functions are there which are satisfying this condition, that g of 3, this is twice of g of 1, and then probability will be number of favorable cases by total number of cases. So the given set, here the function is defined from S to S, that means domain is S and codomain, that is also S. Right, so first set is S. In this set, we have elements like 1, 2, 3, 4, 5, and 6. These are the 6 elements in first set. And the second set is also same set. Right, second set is also S. The function is defined from S to S. And so the codomain is also same set. In codomain, we have these 6 elements. Now remember, whenever number of elements in two sets are equal, right? First set, whenever the number of elements in domain and codomain is equal, then a function is onto function when it is 1 1 function. right? Number of 1 1 function will be same as number of onto function, right? So because once you make function many one, then you cannot make it onto. Onto means codomain is same as range. The meaning of this word onto function will be that codomain and range, these two are equal. So in codomain we have 6 elements, 1 2 3 up to 6, and in range you cannot have more than 6 elements, right? Range will be f of 1, f of 2, and so on. And function means for each element we can have only one image, right? For any one element of set A, there will be only one value of f of 1, f of 2, and so on. So if two sets have equal number of elements, then number of onto function, this is same as number of 1 1 function. So here if we talk about number of elements in sample space, this will be number of 1 1 function from set S to S. And that will be nothing but 6 factorial, because for this first element 1 we have 6 options, right? For this element 1 we can connect either with 1 or 2 or 3, any one of these 6 elements. Let us say f of 1 is 2. Now for 2 we have only 5 options, right? Because we have to make function 1 1. So for the next element 2 we have only 5 options, either it will be 1 or 3 or 4 up to 6. Let us say if f of 2 is 6, then for f of 3 we have only 4 options, and so on. So number of functions, this will be 6 into 5, number of 1 1 function, which is same as number of onto function when we have equal number of elements in two sets. So this will be 6 into 5 into 4 up to 1. So that is 6 factorial. Now let us try to figure out that how many favorable cases are there, right? If we find a number of favorable cases, so then we can get the probability that a randomly selected function will satisfy this equation, that z of 3, this is twice of z of 1. So favorable cases are all those cases where uh, we have this condition satisfied, that z of 3, this is twice of z of 1. Now the same relation you can write in this form, that z of 1, this should be half of z of 3, right? Now let us figure out that how many different possibilities are there for z of 3. Now because z of 1 has to be half of z of 3, and all of these are integers only, so z of 1 will be integer. So from there we can conclude that z of 3, this must be even number, because if z of 3 is an odd number, then z of 1 will become fraction, and we do not have fractional numbers here. So for z of 3, we can take only those values which are integer, which are even integer. So for example, if I calculate z of 3, you can take z of 3 either as 2, or you can take 4, or you can take 6. But you cannot take z of 3 as 1, because then z of 1 will become 1 by 2. We cannot take z of 3 as 3, because then z of 1 will be 3 by 2, right? So for connecting this element 3, we have 3 options. Let us say E is the event that a randomly selected function is satisfying this condition. G of 3 is twice of g of 1. So number of elements in E, or the number of onto functions satisfying this condition, will be, for 3 we have two options. Either you can select 2, or you can select 4 or 6. Right? G of 3 will be either 2 or 4 or 6. We cannot have odd values for G of 3. So for Z of 3, 3 options. Now, once you decide Z of 3, Z of 1 has to be half of that. So for Z of 1, there is only one option. Let us say in this example, suppose if Z of 3 was 2, then Z of 1, this must be half of 2, which will be 1. So Z of 1 has to be 1. And for remaining 4 elements, there is no restriction, right? So for 3, we have 3 options, either 2 or 4 or 6. For 1, there is only one option. Once you decide z of 3, z of 1 is half of that. And then for remaining 4 elements, we have 4 options. I mean, for this element 2, we have 4 options. For 4, we have 3 options, and so on. So these are the number of favorable cases, or the number of matrix, or the number of functions satisfying this condition, right? So because I mean, for these remaining elements, for example, 2, there are 4 options. You can connect with any one of the remaining 4. Then for 4, we have only 3 options, right? And similarly, for 5, we have only 2 options. Either it will be 4 or 5. And similarly, for last one, we have only one option. So for the remaining 4 elements, we have 4 factorial number of options of connecting with the second set, right? So number of onto functions satisfying this condition, this will be 3 into 4 factorial. Now the question is, what is the probability that a randomly selected function will satisfy this condition? So these are the number of favorable cases, 3 into 4 factorial, and total number of onto function, this is 6 factorial. So probability will be 3 into 4 factorial by 6 factorial. 4 factorial you can cancel, and then you have 3 and 6 and 5. So 1 by 5 into 2, that will be 10. So this will be the required probability, right? 1 by 10 is first option, and therefore that should be the correct answer. So this was a problem from functions as well as probability. First of all, onto function means codomain is same as range, and if two sets have equal number of elements, then number of onto function is same as number of one function. So here number of elements in sample space, this will be 6 factorial. And favorable cases means those onto function which are satisfying this condition, that z of 1 is half of z of 3. So for z of 3 we had only 3 even options, either 2 or 4 or 6. For z of 1 only one option, and for remaining 4 elements 4 factorial, and therefore probability will be number of favorable cases by total number of cases. Finally we got 1 by 10, and that is the correct answer for this problem. A coin is biased so that probability of head is 3 times probability of tail, right? Head is 3 times as likely to occur as tail. The coin is tossed until we get a head or we get 3 tails, right? So for example, if the first toss has resulted in head, then we'll stop tossing the coin. But if the first toss is tail, again we'll toss the coin. If the second toss is head, again we'll stop tossing the coin. And if second toss is tail, again we'll toss the coin, and there will be maximum 3 tosses, right? So if x is representing the number of tosses of the coin, we have to find the mean or the expected value of x, right? X is representing number of toss, so we need the mean or the expected value of x. Now this is a problem on random variable and its expected value or the mean. First we have to write the sample space, then we have to see what are the different possible values of x, right? After that we'll need to create probability distribution table, and then we have to see that what should be mean or the expected value of x. Now first of all, the coin is biased coin. That means chance of getting head and tail is not same, because given that head is 3 times as likely to occur as tail, so that means probability of head, this is 3 times probability of tail. Also, probability of head plus probability of tail, this must be 1, because we'll get any one of these two outcomes. So by solving these two equations, you will find that probability of head, this will be 3 by 4, right? In place of probability of head, we can substitute here. So probability of head will be 3 by 4, and probability of tail, this will be 1 by 4. So these are the probability of head and tail. If we have unbiased coin, then probability of head and tail is same. If we have biased coin, then it will be mentioned that what is probability of head and tail, or some other information will be given. From there you can find probability of head and tail. So these are the probability of getting head and tail. Now here if we talk about sample space, there are different possibility, right? Using tree diagram, you can very easily write the sample space. So if the first toss has resulted in first toss, you can get either head or tail. If the first toss has resulted in head, you will stop tossing the coin. But if the first one is tail, there will be second toss, and in that you can get either head or tail. Again, if the second toss is head, you will stop tossing the coin. But if it has resulted in tail, there will be third toss in which you can get either head or tail, and there will be maximum 3 tosses. So here the sample space will be either you can get head in first toss, right? In first toss of coin, you got head, you stopped tossing the coin, or first one is tail, second one is head. This is another possibility. Or first two tosses has resulted in tail. Now third one will be either head or tail. So these are the 4 possibilities, right? These are the 4 events in the sample space. Now x is representing the number of tosses of the coin. So as you can see that the value of x will be either 1 or 2 or 3. So let us create the probability distribution table for x. On one side we'll write x, and on another side we'll write probability of a particular value of x. So let us say here we have x, and here we have probability of that particular value of x, right? So one possibility will be that x is 1. If the first toss has resulted in head, there will be only one toss. We'll see what is the probability of that one. Next possibility is that the value of x is 2. X is 2 if first toss has resulted in tail and the second one is head. And finally, the last possibility is that there will be 3 tosses, right? These are the 3 different cases. Now, once we create the probability distribution table, we have standard formula for finding the mean or the expected value. So probability that x is 1, this will mean that first toss has resulted in head. Now remember here, all of these events, they are not equally likely event. So you should not say that probability of this particular event, this will be 1 by 4. This will be incorrect. Why? Because all of these events are not equally likely. Right here, I mean, obviously the chance of getting head in first toss is not same as chance of getting tail in first and head in second. Right? So here the correct approach will be that probability of, I mean, there will be only one toss if the first toss has resulted in head, and the probability of getting head, this is 3 by 4 because the coin is biased. So probability of head is 3 by 4 and probability of tail is 1 by 4. So probability that x will be 1, this is 3 by 4. Similarly, probability that x is 2, this will be probability of getting tail head. Right? There will be second toss only when the first toss has resulted in tail and the second one is head, right? There will be 2 tosses. If first one is tail, second one is head. And because these are independent event, you can use multiplication rule. So this will be probability of getting tail in first, head in second. Tail in first 1 by 4, head in second 3 by 4. So this becomes 3 by 16, right? So this number x equals to 2, 3 by 16. Let us create common denominator. So we can write this as 12 by 16, right? This will be 12 by 16. And now sum of all the probabilities should be 1. So from there you can very easily see that this number must be 1 by 16, probability that x is 3. Or another way of saying that thing will be that there will be 3 tosses. If first 2 toss has resulted in tail, right, whatever be the third toss, if first 2 toss has resulted in tail, then there will be third toss, right? So I mean x equals to 3, these two cases, and their probability will be probability of getting 2 tails. You can use multiplication rule because these are independent event. So this will become 1 by 16. So either you can find from here, or we know that sum of all the probability must be 1 because these are all the cases. So from there also you can write this value. And now the expected value of x, this will be p1 x1 plus p2 x2 plus p3 x3. Right, this is the formula for expected value or the mean of x. So 1 into 12 by 16, so that will be 12 by 16, plus 2 into 3 by 16, so that will be 6 by 16, plus 3 into 1 by 16, so that is 3 by 16. So I think after adding this, you will get 21 by 16. So therefore, the correct answer for this problem will be 21 by 16, which is option C. Right, so this was not difficult problem, standard formula. Biased coin means probability of head and tail is not same. And from, I mean, from the given information, we got probability of head as 3 by 4, tail 1 by 4. And now we have to write the sample space. Sample space will have these 4 elements, either one head, tail head, and so on. Then create probability distribution table. And this is the standard formula for finding the mean or the expected value, right? Sigma pi xi. After calculation, finally we got 21 by 16, and therefore the correct answer for this problem is option C. In a tournament, a team plays 10 matches with the probability of winning and losing each match 1 by 3 and 2 by 3. Right? This probability is constant. Probability of winning every match, probability of winning each match is 1 by 3 and losing the match is 2 by 3. So, and sum of these two is 1, so there is no chance of draw. These are the only two cases, right? X is the number of matches that the team wins, and Y is the number of matches that the team loses. If probability that mod x minus y, this is less than or equal to 2, this is p, then we have to find the value of 3 raised to 9p. Now, this is a problem on binomial distribution, right? We know that if we repeat the same experiment n number of times, then probability of R success in n trials, X is representing the number of success. So probability of R success in n trials, this is given by the formula NCR, P raised to R, where P is probability of success, and Q raised to n minus R. Q is probability of failure, which is 1 minus P. So this is the standard formula in case of binomial distribution, right? If we repeat the same experiment n number of times, and P is the probability of success in each trial, Q is probability of failure in each trial, and these two are constant for every trial. So then probability of R success in n trial, this is NCR, P raised to R, Q raised to n minus R. Now here it is given that probability of winning the match, this is 1 by 3. Probability of losing the match, this is 2 by 3. And then we have to find that difference between win and loss. This should be 2 or less, right? This probability is P. Then we need to find value of 3 raised to 9 into P. Now see here, first let us see what are the different possibilities. When X is representing number of win, for loss, y is representing number of loss, and mod x minus y, this should be less than equal to 2. So one case will be, the very first case will be that you win 5 matches, lose 5 matches, the difference will be of 0, right? X minus y, that will be 0. Another possibility will be that you win 6 matches, that means you will lose the remaining 4 matches, difference will be of 2. We cannot win 7 matches because then loss will be 3 and difference will be 4. Difference would be less than equal to 2. Right? This is the important point here, that mod x minus y, that must be less than equal to 2. That means difference between win and loss, that should be 2 or less. So x cannot be 7. In that case, y will be 3, x minus y will be 4. So another possibility will be x is 4, y is 6, and here also difference is of 2. And again, you cannot win 3 matches because in that case you will lose 7 matches, difference will be of 4. So these are the 3 different cases, right? And now we have to find the probability of this thing. P is the probability of this one, so then we have to find 3 raised to 9 into P. So this thing will be 3 raised to 9, and P is nothing but probability of these different cases. First one is 10 win, that means remaining 10 losses, right? Now we'll find probability of 5 win, 6 win, or 4 win. So probability that you will win 5 matches, this will be 10C5, and then P raised to 5, P is 1 by 3, so 1 by 3 raised to 5, Q raised to 5. This will be the probability that you will win any 5 matches and you will lose the remaining 5 matches. Probability of winning 6 matches, this will be 10C6, 1 by 3 raised to 6, right? P raised to R and then Q raised to n minus R. So 2 by 3, this raised to 4. This is the probability of winning any 6 matches. And finally, the last case is 10C4. This is probability of winning any 4 matches. So 10C4, 1 by 3 raised to 4. And then we have 2 by 3, this raised to 6. So these are the 3 different possibility. Now calculation you can do on your own. After calculation, you will find that this number is 8288. Remember, we had to find 3 raised to 9 into P, right? So this will be P, right? This is the probability of 5 win, 5 loss. Second term, 6 win, 4 loss. And the last term, any 4 win, and then remaining 6 losses. After calculation, you will find that the value of this term will be 8288, and therefore that will be the correct answer for this problem. Right, so in this problem, the important step was to figure out the different cases. So just create this table, 5 win, 5 losses, difference will be of 0. And then either you can have 6 win, 4 loss, or 4 win, 6 loss. Right, in that case, difference will be of 2. And then after that, using that standard formula, uh, this will be the required probability. And finally, when you calculate, you will find 8288 is the correct answer for this problem. Let A be the event that absolute difference, that means modulus of difference between the two numbers, two randomly selected real numbers in this sample space 0 to 60. So we are selecting any two number from 0 to 60, and the difference of modulus of those two numbers is less than or equal to alpha. The probability of this thing is 11 by 36. So then we have to find the value of alpha. Now, this is a problem on 2D probability, right? Here, if you see the sample space, we have to select two numbers in this set 0 to 60. And you can take any two numbers from 0 to 60. It is not necessary that those numbers should be integers, right? So we need to pick two numbers from 0 to 60. The difference between those two numbers, right? The difference between those two numbers is less than or equal to alpha. The probability of this thing is given. Probability is 11 by 36. Then what is the value of alpha? Now, see here, let us say that two selected numbers are x and y. So it is given that x is a number in this interval 0 to 60. You can take any value of x from 0 to 60. Similarly, y is a number from 0 to 60. Again, you can take any numbers from 0 to 60. Now, there are infinite number of numbers from 0 to 60, right? If I mean, it is not given that x and y are integers, so you have infinite possibilities for x and y. And then it is given that the A is the event that absolute difference between those two randomly selected number is less than or equal to alpha. That means mod x minus y. This is less than equal to alpha. And the probability of this thing is 11 by 36. So then what should be the value of alpha? Now this is a question on 2D probability. Right? There are two variables x and x and y can take any value from 0 to 60. So first let us first let us plot the sample space here, and then we'll see uh, what is the favorable reason in that. So if x and y are numbers from 0 to 60, so that means for x we can take any value from 0 to 60, and same thing is true for y also. That means we can take any points inside this square. Right, the different lines are, this line is x equals to 60 line. Here we have x equals to 0. This is y equals to 60 line. And this is your sample space, right? Take any point in this region and it will satisfy the condition that x is between 0 and 60, y is also between 0 and 60. So this square is representing the sample space. Let us call these points as O, A, B, and C. So this square is representing the sample space here, right? Now the favorable reason will be that mod x minus y, this should be less than or equal to alpha. That means x minus y, this should be between minus alpha and plus alpha. Obviously, alpha will be a positive number, right? So the favorable reason will be reason satisfying this inequality, that x minus y is between minus alpha and plus alpha. So first let us plot this line x minus y equals to alpha. So when x is, I'll remove this point and the coordinate of this point will be, point B is 60 and 60, right? This line also we can remove. So if I draw this, one line we have to draw is x minus y equals to alpha. Other line we have to draw is x minus y equals to minus alpha. And then we'll see that which reason is represented by this inequality, because this will be the favorable reason, right? So here, if I make, for drawing the first line, if I make y 0, x will be alpha, and the line is having slope 1. So basically, this will be the line x minus y equals to alpha, right? This is the line x minus y equals to alpha. And the other line x minus y equals to minus alpha, this will be a line parallel to this one. And if I make y 0, then you will get x as minus alpha, and if you make x 0, then you will get y as plus alpha. So this should be the other line, right? The second line will be passing through this point, these 2 points, and the equation of this line will be x minus y equals to minus alpha. And now this inequality will represent all the points between these two lines, right? Clearly origin is satisfying this inequality, so that inequality will represent all the points inside this region. That means take any point in this shaded region, and that point will satisfy the condition that mod x minus alpha is less than mod x minus y is less than equal to alpha. So this is your favorable reason, right? The sample space will be the square here, right? Take any point inside the square, and for that point x and y will be between 0 and 60, and the favorable reason will be the area shaded in green, yellow color, right? The area between these two lines. Now we know that in case of 2D probability, the required probability is favorable area divided by total area, and it is given that the required probability is 11 by 36. So 11 by 36, this must be favorable area, and this divided by total area. And from there, we need to find the value of alpha, right? So clearly you can see that total area will be area of a square, and for a square, the side is 60. So therefore, area of that square will be 60 square, right? So in denominator, we'll get 60 square, and the numerator part will be, we have, you can see that basically we need to remove these two area, right? This area highlighted in green color, this is not favorable area. So if I need the favorable area, this will be 60 square, that is area of a square, minus the area of these two triangles. Now this point was 60, 0. This point will be alpha 0. So for this triangle, one side will be 60 minus alpha. And also from symmetry, you can clearly see that these two triangles will have equal area. So 2 into area of these two triangles, half into base into height. Now base will be 60 minus alpha, and because for this line the slope is 1, this angle will be 45, and that means these two sides will be equal. So the other side is also 60 minus alpha. So this is the equation that we are getting, and you can solve this equation on your own. After solving, you will find that alpha is 10. So therefore, that will be the correct answer for this problem, right? So in JEE Main, generally you will not find problems on 2D or 3D probability, but when this was one problem from 2D probability, because when x and y can take all the values from 0 to 60, right? So x is a number from 0 to 60, y is a number from 0 to 60. So any point inside this square is a point in sample space, right? And then favorable case will be all those values of x and y satisfying this inequality, that mod x minus alpha is between minus alpha is less than equal to alpha. That means x minus y is between minus alpha and plus alpha. So plot these two lines, and then that inequality is representing the area bounded between these two lines. Probability, in case of 2D probability, the required probability is favorable area by total area. So from there we got this equation, and after solving we got alpha as 10, and hence the correct answer for this problem will be 10.